The next time we see the Starship, it could be launching from a brand new ultra-modern pad. Yes, SpaceX is hard at work on its latest launch pad, the OLM-B, and this new facility boasts some truly incredible features you won't want to miss. But why is SpaceX investing in a new launch pad? How will this impact the Starship's liftoffs, and what will happen to the current launch pad? I've got all the answers to these questions right here in today's video, so let's dive in. The OLM-B, SpaceX's new launch pad. SpaceX has made significant progress with its Starship and at the same time with its Orbital Launch Mount A, or OLM-A, also known as Pad A. This launch pad is a monster in its own right, standing 65 feet high with a 40-foot diameter at its base. Imagine bearing the weight of the world's largest rocket booster. Pretty wild if you ask me. The new launch pad OLM-B takes this achievement even further. Planned to be ready by January the 28th, 2025, this new launch pad will feature some truly incredible upgrades and is expected to perform even better than Pad A. Before we continue though, make sure to hit that subscribe button and share this video with your fellow space enthusiasts. If you do that, I'll make sure to keep you updated on every launch, all the news and surprises in the world of space. So give this video a thumbs up if you're excited and ready for a liftoff. Now, in addition to supporting the weight of the current V2 model of the Starship Super Heavy stack, the new launch pad will be able to handle the even larger V3 model, which will stand around 150 meters tall and launch with a thrust of at least 10,000 tons, statistically much higher than the current 8,000 tons. You might be wondering, how will the new launch pad bear this enormous weight and massive thrust? Well, it all comes down to how it's built. The answer is all in this video. The launch mount. The most visible part of OLM-B consists of a launch mount with a large flame diverter. That's right, SpaceX is now opting to use a flame diverter to handle the Super Heavy's intense blast at liftoff and the massive cloud of fumes that follows. The cuboidal launch mount itself is divided into top and bottom halves. The upper section has a circular cutout at its center, similar to the opening in OLM-A. The circumference of this opening aligns perfectly with the base of the Super Heavy booster, leaving just enough space between them. This circular opening will accommodate the hold-down clamps and Raptor quick disconnects, which are essential for igniting the outer ring of the Raptor engines during liftoff. The lower section of OLM-B features a significantly larger square cutout. This cutout not only supports a substantial portion of the Super Heavy, but also helps maintain the rigidity of the upper section. Additionally, it serves as the connection point between the entire mount and the flame diverter. Both parts of the launch mount will be constructed from reinforced steel and durable steel plates. Internally, there will also be a crisscross of large steel bars. As a result, this mount will be considerably heavier than the OLM-A mount. Another remarkable feature of OLM-B is its planned mobility, at least when detached from the flame diverter. While the specifics of how SpaceX intends to achieve this remain unclear, it's evident that the company has the engineering expertise, though, to make it happen. This enhanced mobility would simplify repairs to the launch pad, allowing for quicker maintenance and potentially increasing launch frequency. Just imagine a launch base that can be moved around. Pretty futuristic if you ask me. Then again, it's not SpaceX's first time attempting something bold. Remember the catch maneuver? But trust me, this isn't even the best part about the new launch pad, so let's go underground. The dual flame bucket. Underground, the new launch pad will feature a spectacular system called the dual flame bucket. As odd as it might sound, it is actually incredible and very useful. The dual flame bucket system consists of high-quality super tough steel slides that collect and redirect the rocket's exhaust fumes during liftoff in two directions. Compared to the flame diverter, the dual flame bucket utilizes a much deeper trench and can manage the explosive force of the rocket's launch more effectively by creating a larger area to deflect the flames and gases. Thanks to Chrome Kiwi on X, we now have images of the layout of the dual flame bucket. The dual flame bucket consists of two sides facing opposite directions, with their apices directed towards the base of the Super Heavy when mounted on OLM-B. On these inclined steel plates, the fumes will flow down and then be channeled up and out far from the launch area, thereby reducing the heat and pressure generated and protecting the launch pad from extreme damage. As you can see in the photos, the flame bucket will begin with a rectangular frame as its foundation, featuring strong attachments for the bases of the inclined steel plates. The trench will be reinforced with concrete for stability and will also include a manifold system to channel water into the launch pad, similar to the water deluge system of Pad A. The water system of Pad B will likely be much more robust and sophisticated, especially considering the immense heat and pressure the launch pad will experience once the Super Heavy fires up. Meanwhile, the Super Heavy booster B-13, which will be used for the 6th test flight of the Starship, will feature several upgrades to its Raptor engines compared to the B-12 used in the 5th test. Notably, it will transition from the Raptor 2 to the newly designed Raptor 3 engines. The Raptor 3 engines are not only 7% lighter than their Raptor 2 counterparts, but they also generate approximately 280 tons of thrust, around 21% more than what the Raptor 2 produces. Additionally, the V3 model of the Starship Super Heavy stack may use 35 Raptor engines in the Super Heavy rather than the current 33. Yes, that's an increase in Raptor engines, and not just the standard Raptors. We're talking about the V3 shuttle booster combination too. Indeed, the new launch pad and its dual flame bucket will need to be exceptionally strong. Now, we can't say for certain whether both the dual flame bucket system and the flame diverter will be used, especially considering that both structures perform the same function: flame and fume redirection. However, SpaceX might decide to utilize both, as this would reduce the pressure on either redirector and help maintain the durability of the launch pad. I believe SpaceX should implement both redirectors for the new launch pad, at least if it's feasible. Additionally, I'd suggest that the flame bucket system should use a 3-directional diversion instead of just 2. With a third inclined steel plate, the pressure could likely be reduced more quickly and the heat could be managed more effectively. Let me know what you think about this in the comments. But let's ask the big question here: why exactly does SpaceX need a new launch pad? The need for OLM-B, a magnificent launch pad, arose when SpaceX realized that the existing OLM-A would not be able to handle the type and frequency of the launches they had in mind. SpaceX has ambitious plans for the Starship, one of which is to launch frequently once it's ready. Regarding its readiness, the space company is working around the clock to ensure everything is completed on time. The 6th test flight of the Starship is scheduled for November the 11th, 2024, exactly 4 weeks after the 5th test flight on October the 13th, 2024. While the same OLM-A used for the 5th flight will likely be utilized for this launch, SpaceX has invested significantly in its preparation. After the 5th test flight, Pad A encountered several issues due to the heat generated during liftoff and the salty air conditions around the pad. The metallic pipes in the water deluge system began to rust, gradually reducing the structural integrity of the launch pad. Additionally, the launch pad's paint had come off due to the heat, further exposing more surface area to the rusting process. While SpaceX is in the process of addressing these issues, it's clear that Pad A is not as durable as it was before. However, if the shuttle and boosters used are similar in weight and thrust power to those used in the 5th test flight, then the pad should work well for the 6th flight. That said, we can't place 100% trust in it. Additionally, SpaceX will need a new launch pad even if OLM-A were perfect. In preparing for the V3 models of the Starship Super Heavy combination, SpaceX will require a much larger and stronger launch pad, one that won't disintegrate as the original pad did during the first test flight of the ship. Speaking about the new launch pad on X, formerly Twitter, Elon Musk said, The new Launchpad is already designed for the 10,000 tons of thrust version, which is almost exactly 3 times more powerful than the Saturn V moon rocket. Elon has compared the thrust power of the V3 series, which is around 10,000 tons, to the Saturn V rocket, which produces only about 3,400 tons of thrust. In other words, the V3 series would significantly overshadow the Saturn V rocket. If OLM-B can withstand the liftoff thrust of a V3, then it will be relatively more durable than the Launchpad at the Kennedy Space Center in Cape Canaveral, Florida. Additionally, once the current V2 series is ready for missions like the Polaris mission and the Artemis program, SpaceX's Starship launches will skyrocket, and the Super Heavy may be used many more times than the Falcon 9 has ever been. Thus, a Launchpad durable enough to support multiple launches will be required, and OLM-B is definitely suitable for that purpose. If OLM-B proves its durability in the early part of 2025, SpaceX may want to create more launch pads at its other sites, particularly in Florida and California. Indeed, this would represent another giant leap for mankind. With that, we come to the end of this video. If you've enjoyed watching, hit the like button, share it with your friends, and subscribe to Space Minds for the latest updates on our space news and adventures.